With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
So in this question, we have to evaluate this following integral, and the integral is, let this integral be I. So I is integral 0 to 2 pi, and we have e raised to power x by 2, and sine of we have x by 2 plus pi by 4 with respect to dx. So we have this integral, and we have integral of e raised to power ax sine bx with respect to dx here. In this type of questions, we try to make them by applying by parts. So this will be the first and this will be second. So we have applying by parts. We have this is I. So first as it is, we have first as it is sine bx as it is, integration of second, that is integration of e raised to power ax, minus differentiation of first, that is cos of bx into b. We have b outside, and we have integration, differentiation of first into integration of second, that is integration of e raised to power ax dx. So if we further solve this, we have sine bx, and integration of e raised to power ax is e raised to power ax upon a, and minus of we have b, and integral of this term here is, we have integration of e raised to power ax is e raised to power ax upon a. So upon a is here, and we have cos of bx here with respect to dx. So if we further apply by parts, we have this is second, this is first function. So further applying by parts, we have here will be sine bx e raised to power ax upon a, and we have minus of b by a, and applying by parts, we have first as it is, that is cos bx as it is, into integral of e raised to power ax minus differentiation of first, that is minus minus will be plus of, here will be sine of sine bx, and we have differentiation, so we have b outside, and integration of second, that is integration of e raised to power ax is e raised to power ax upon a, and we have with respect to dx here. So if we further see this term here is written nothing but integral I. So I is equal to this term we have. So taking this term common, we have, taking I common from here, we have 1 minus, here will be b by a, and we have sine of sine b x into e raised to power ax upon a, and minus of, if we see this, we have b by a, here will be cos of bx, we have cos bx, and integral of this will be integral of ax upon a, we have, because integral of e raised to power ax is this, and we have this term here is, and it will be, because here is minus sign, so minus plus will be minus, so here will be minus, so after going there it will be plus of 1 plus b by a. So here will be this term left. So, and we have one more thing, that is b by a into this b by a will be, here will be b square upon a square. So this will be the answer. So we have I is equal to 1 plus b square upon a square, and we have this whole term. So if we take this a square common, we have 1 upon a square, here will be sine bx e raised to power ax, and here will be a, because we have taken a square common, and minus of, we have b here, and cos of bx into e raised to power ax here. So if we see this, we have I into a square plus b square. Here a square in denominator will be cancelled out with this a square. This a square and this a square will cancel out, and we have a sine bx e raised to power ax minus of b cos bx e raised to power ax here. So I is equal to, we have a sine bx e raised to power ax minus of b cos bx e raised to power ax, and in denominator we have a square plus b square. So this is the value of integral e raised to power ax sine bx. So if we put the values of a and b, and we have integral as 0 to 2 pi, we have e raised to power x by 2 sine of x by 2 plus pi by 4. So we have this term. So on putting x by 2 plus pi by 4 as t, so we have 1 by 2 dx is dt. So we have here will be dx is 2 dt. So we have this term as, if we put x is equal to, at x is equal to 0, we have t is equal to pi by 4. T is pi by 4. And when x is equal to 2 pi, when x is equal to 2 pi, here we have 2 pi. So this 2 will cancel out. Pi plus pi by 4 is, t is 5 pi by 4 here. So we have integral pi by 4 to 5 pi by 4, and limits will be, we have e raised to power x by 2, and x by 2 is t minus pi by 4. So we have e raised to power t minus pi by 4, and we have sine t, and dx is, here will be dx, so dx is 2 dt, so 2 outside, and we have dt here. So if we take this e raised to power minus pi by 4 in denominator, we have this value is 2 upon e raised to power pi by 4 here, and we have by using the properties of exponents here. So we have pi by 4 to 5 pi by 4, and this value, this term is e raised to power t sine t with respect to dt here. So in this case we have a is equal to 1, b is also 1. So we have this value will be equal to, this whole value is equal to, we have 2 upon e raised to power pi by 4 as it is, and we have this value as sine of x into e raised to power x. So we have e raised to power t sine t minus e raised to power t cos t, and in denominator a square plus b square is 1 square plus 1 square is 2 here, and we have the limits from pi by 4 to 5 pi by 4 here. So putting upper limit minus lower limit, we have this 2 and this 2 will cancel out. So we have 1 upon e raised to power pi by 4, and this will be e raised to power, here will be e raised to power 5 pi by 4 sine 5 pi by 4, and we have minus of e raised to power 5 pi by 4 cos 5 pi by 4, and we have minus of, if we see this, we have e raised to power pi by 4 sine pi by 4, and minus of e raised to power pi by 4 cos pi by 4 here. So if we solve this, if we multiply it inside, we have e raised to power pi sine 5 pi by 4 is minus 1 by root 2, and we have minus here, and this will be e raised to power pi, here will be minus 1 by root 2, and minus of, if you multiply this term here is 1 by root 2 and minus of, we have 1 by root 2 here. So if we see this, e raised to power pi common, and we have minus 1 by root 2, and this minus plus, minus minus will be plus 1 by root 2, and this term here is 0, here will be 0, and if we see this term, here will also be 0. So whole 0 into something is 0. So I will be equal to 0. This will be the final answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.